Welcome back to section 4 of chapter 6. In this section, we are going to be looking at factoring polynomials. This is a direct extension to dividing polynomials, which we were doing last time, and it will lead us into solving polynomials, because just like with quadratics, where we solve by factoring, we're going to be solving a lot of polynomials by factoring as well. The process is remarkably the same, except we'll end up with more factors. So let's look to see how we can factor polynomials. First, our learning targets. The first learning target, I can use the factor theorem to determine the factors of a polynomial. This will make more sense when we see what the factor theorem is. The second one, I can factor the sum and difference of two cubes. Yes, and you'll actually be factoring a few more things other than just sum and differences of two cubes. So, factoring. What is this factor theorem we've been hearing so much about? The factor theorem states that for polynomial p of x, x minus a is a factor if and only if p of a equals 0. So what that means is that when we plug it in, we get 0. If we remember back to the remainder theorem from last time, when we plugged it in, we got the remainder, or vice versa. The remainder is what we would get if we plugged it in. It works both ways. And so, plugging it in, getting 0, means that we'll have a remainder of 0, which means that it goes in evenly, which is the definition of a factor. So, that really makes sense, and here's that remainder theorem coming back to help us. One thing to notice here, all of a sudden we have p of x instead of things like f of x. Why the p of x? Well, p of x specifically signifies polynomial. F of x could be a whole lot of things. It's very generic. So p of x, they mean the same thing for all intents and purposes, but for polynomials, we tend to use p of x. So, factor theorem, how do we use it? We're going to tell, is something a factor? So let's get a polynomial and a factor. Is it a factor? Is x minus 8 going to be a factor of p of x equals x to the 5th minus 8x to the 4th plus 8x minus 64? There are a couple different ways that we could do this. We could take 8 and plug it in. 8 to the 5th minus 8 times 8 to the 4th plus 8 times 8 minus 64. I would not recommend that for a couple of reasons. One, that first one, 8 to the 5th, I know I don't particularly want to think about that. Secondly, the other method, which will be synthetic substitution, which we saw last time, is much faster, much easier. And finally, when we are factoring to solve, we're going to have to do it a couple times in a lot of cases, and that's only going to be possible through synthetic division, synthetic substitution. So I would just get in the habit of doing it. It's great practice, and your synthetic division process should be speeding up significantly. So let's do that. So we have x minus 8, so it'll be a positive 8, and then get our coefficients. Notice we have zeros for our placeholders for x cubed and x squared. In this case, it actually won't make a difference, but it's important to have them anyway. So we bring the first number straight down, then times 8, add is 0, and this is why it actually won't make a difference if we forgot, because this is 0. If it's not 0, it makes a big difference. So it's always good to have them. Anyway, 0 times 8 is 0, plus 0 is 0, times 8 is 0, plus 0 is 0, times 8 is 0, plus 8 is 8, times 8 is 64, negative 64 plus 64 is 0. And so out of this whole big thing, I don't care what the rest of the polynomial is when we divide. All that's important here is this remainder. And yes, I just circled 0. I thought it would be fun. Looking at the remainder, we have to ask ourselves a question. Is the remainder 0 or is it not 0? In this case, yes, it is 0. And so yes, x minus 8 is a factor. If it is not 0, then no, x minus 8 is not a factor. So what would some examples of not 0 be? You might be thinking of one. When you comment, just put that not 0 number in the comment. Let's see if we can confuse people that aren't actually watching and just posting, I watched it. See what happens. So, is it a factor? Yes, because it's 0. Synthetic division, that's all it is synthetic division, what we were doing yesterday. So, let's see if you can do one. The process is what we've already done. So try this, try a big one. Is it a factor? P of x equals 4x to the 6th minus 12x to the 5th plus 2x cubed minus 6x squared minus 5x plus 10, and you're checking x minus 3. So go ahead, do this with synthetic division. Pause the video and come back when you're done. Welcome back. How did it go? Is the synthetic division process getting a lot faster yet? If not, it will be. So let's set it up. We have x minus 3, so it'll be plus 3, and then get our coefficients. Notice we have the 0 for the placeholder for x to the 4th. All right, and then the 4 comes straight down, times 3 is 12, add is 0, times 3 is 0, plus 0 is 0, times 3 is 0, plus 2 is 2, times 3 is 6, negative 6 plus 6 is 0, times 3 is 0, plus negative 5 is negative 5, times 3 is negative 15. Add them, we get negative 5. So the question is this negative 5 0? And the answer is no, it is not. And so no, x minus 3 is not a factor of this giant polynomial. And so those questions, is it a factor, are really just yes/no questions, but you do have to have the work to back that up. So that's using the factor theorem. Again, it's a pretty easy factor theorem. So let's look at some factoring techniques. We have several techniques we're going to look at today, and we will be building on this in the next couple topics. Today, though, we're going to be looking at numbers of terms for the most part. First, if we have two terms, we're going to use what are called special factors. We have several special factors that we'll use. The first one we actually saw last chapter, and that's going to be the difference of squares. If we have something squared minus something squared, how does it factor? Well, it factors to, if a squared minus b squared is a plus b times a minus b. If we were to multiply this out, we'd have a squared minus ab plus ab, those go away, minus b squared. And so that's going to give us the difference of squares. If we have something squared minus something squared, take the square root of each of them and plug them in here. One's plus, one's minus. So how does this look? If we have 4x to the 8th minus 81, that's something squared minus something squared. 4x to the 8th, 4 is 2 squared. X to the 8th is x to the 4th squared. You just have to divide the exponent by 2. And then 81 is 9 squared. And so our a is 2x to the 4th. Our b is 9. We can just plug them into the formula. We get 2x to the 4th minus 9, 2x to the 4th plus 9. That would be using difference of squares. It's just bigger than what we had last chapter. Last chapter was like x squared minus 9. So you got x plus 3x minus 3. The other two are going to be of cubes, and we actually have sums or difference of cubes. So there's two equations, but you really only need to remember one. I'll show you why when we get there. So the first one is a sum of cubes. We have something cubed plus something cubed. Well, we have to figure out what the cube root is, and that goes here, a plus b, then a squared minus ab plus b squared. Notice they're all plus except for this minus here. The second one is difference of cubes, And it's the same except it's minus. Here, the minus change is not in this location anymore. Instead, it's over here. Notice each of these has exactly one minus sign, either right in front of the AB or in the A plus B. And notice this first piece is the same as what it started out as. That's how I remember it. I mentioned you only really have to remember one of these. That would be the top one, the sum one. If you had subtraction, let's say like this one, if you just made this a cubed plus negative b cubed, and then made all the b's negative, that changes the sign there, it'll change the sign here, and negative b squared is still going to be a positive b squared. And so this second one is really just a special case when b is negative. You can figure it out without. So let's look at what these look like. If we have something like 125 plus z cubed, this is something cubed plus something cubed. What cubed is 125? If you're thinking 5, you're thinking well. What cubed is z cubed? Well, that's z cubed is z cubed. So the a is going to be 5, the b is going to be z, and we just need to plug the 5 and the z into the equation. We get 5 plus z, 5 squared is 25, minus 5z plus z squared. And we're done. That's all it is for sum or difference of cubes. So let's take a look at another one. We have 4 minus 5t cubed. And you might be looking at that thinking, or not 40 minus 5t cubed. You might be thinking, 40, what cubed is 40? And for that matter, what cubed is 5? We have a step. Before we do any of this factoring, we have a step. And that was going to be factor out what they have in common. Hey, both of these are divisible by 5. Let's factor out a 5 and see what's left. What's left? 8 minus t cubed. Because if we distribute the 5 times 8 is 40, minus 5 times t cubed. So we factor out the 5. 8 minus t cubed. 8 is something cubed. T cubed is something cubed. And so we can use that 2 and t and just plug them into the bottom one. And the question is, well, what do we do with this 5? Absolutely nothing. Stick it on the front. It goes along for the ride. That's all that happens. So we have 5 times a minus b. That'll be 2 minus t. 2 squared is 4 plus 2t plus t squared. And that's your difference of cubes. The hardest part of these is just remembering the formula. Is it a super important formula to remember? Today, yes. In the long run, no. You can get around it by going through the process we'll learn in a couple days. It's a longer process, but yeah, it works. So that's if we have 2 terms. How about if we have 3 terms? We can factor it like a quadratic. If we have something like x to the 4th minus 3x squared minus 4, that looks a lot like x squared minus 3x minus 4. And we can factor that. The difference is, instead of x plus something, x minus something, we're going to have x squared plus something, x squared minus something. And you can do this anytime this exponent is exactly 2 times this exponent. So if we had 6 and 3, 8 and 4, 20 and 10, generally speaking, it's going to be a 4 and a 2. Maybe, like the challenge type problem, a 6 and a 3. But usually it's going to be 4 and 2. So when we factor this, we'll have x squared and x squared. And we just have to think, what times what equals negative 4 and adds to give negative 3? Well, negative 4 could either be a 2 and a negative 2, which isn't going to add to give us negative 3, or a 4 and a 1, so that could be a negative 4 and a positive 1. And sure enough, that will work because negative 4 plus 1 is negative 3. And so we have x squared plus 1, x squared minus 4. It's factored like a quadratic, right? Yep. And so we're done, right? Maybe. We do have to check. We have two terms here. Do we have difference of squares or some are difference of cubes? Well, these are both squares, so we don't have to worry about cubes. X squared plus 1. No, we need something squared minus something squared. When it's plus, you're done. X squared minus 4. Is 4 something squared? Yeah, it's 2 squared. So we need to do difference of squares here. X squared minus 4, that's going to be x plus 2, x minus 2. And so we just change that there. The x squared plus 1 just hangs on the front. We don't do anything with that. We just factor these guys to make sure we have it completely factored. But this first step was the quadratic. And so that's if we have 3 terms. Another option, we could have 4 terms. In this case, we're going to factor by grouping. Factoring by grouping is something I don't remember learning in high school, and I wish I had because it makes life a lot easier. So, if we have 4 terms, we're going to split it into 2 groups. And we could also have 6 terms, 8 terms, an even number of terms. Factoring by grouping is a possibility. Generally speaking, we'll have 4. So we're going to split it into 2 groups. We have this first one, 8y cubed minus 4y squared. And we're going to look to see what could we factor out of these 2 things. Well, they both have y's. In fact, they both have y squareds. And then 8 and 4, we can divide both those by 4. So we could factor out a 4y squared. Now we need to figure out what's left. 4 times what equals 8? That'll be 4 times 2 equals 8. And we need another y, so that'll be 2y minus 4y squared. We don't have anything there. And so there needs to be a 1 as a placeholder. So we have 2y minus 1. If we multiply this through, we'd get right back to where we started out with. All right, now we can look at the other side. Negative 50y plus 25. What do these both have in common? Oh, they have a 25 in common. I'm going to go with a negative 25 because I'd really like this one to be positive, and we'll see why in a second. So I'm going to say they have a negative 25 in common. And let's see, so negative 25 times what equals negative 50? That would be 2, then y. Then negative 25 times what equals 25? Negative 1, so 2y minus 1. And now we can see, what do these 2 groups have in common? They both have a 2y minus 1. And so we can factor that out. If we didn't deal with the negative here, we'd end up with a negative 2y plus 1, and we'd have to factor out negative later. So specifically, since your first term is probably going to be positive, I would, if this is a negative, always factor out a negative. So anyway, back to factoring. We have a 2y minus 1 in both groups, so we could factor that out. And then what do we have left? Well, when we get rid of the 2y minus 1 here, we have 4y squared. And the 2y minus 1 here, we have negative 25. So we have 2y minus 1 times 4y squared minus 25. That is factoring by grouping. We split it into 2 groups, factor out what each separate group has in common, and then see if we can factor out what was left. Is that always going to work when you have 4 terms? Not always. But today, that's the tool we have, so it will probably work. And so we factor by grouping, so we're done, right? Well, back to the whole 2-term thing. Here, this is already a linear binomial. It's done. This one isn't yet. That's a possibility we're going to have to factor again. So let's see, it's a y squared, so we don't have to worry about cubes. But is it a difference of squares? 4y squared, that's something squared. Minus 25, that's something squared. And so yes, we do have to deal with difference of squares here. This would be a 2y and a 5, so we'll have 2y plus 5 and 2y minus 5. And the original 2y minus 1 just hangs along on the front. And so this will be completely factored all the way down to linear binomials. That's the goal. If we can get there, that's awesome. Here, it wasn't a possibility. That's okay, but this one's great. So let's look to see what we have so far. Factoring so far. Step 1. Factor out what they have in common. That would be like what we saw over here where they had a 5 in common. Always very, very important to factor out what they have in common. It'll help make the rules work. It'll help make everything else easier. Step 2, look at the number of terms. We have possibilities. We have 2 terms, 3 terms, and 4 terms. If there's 2 terms, is it a special factor? 3 terms, can you factor it like a quadratic? And 4 terms, can you factor by grouping? Later on, the answer very well might be no, and we have to do something else. Today, this is what we know. So chances are, with the number of terms, you will be able to factor using that method. So let's see if you can do that. Oh, then there's more to come. We'll have more steps after that, but not today. So let's see if you can factor some. We have 4b cubed plus 3b squared minus 16b minus 12. Do you have an idea on what method you're going to use on that one? And then y to the 5th plus 25y squared. You know what you might try and use on that one. Think about what you might have to do first. And x to the 6th minus 14x to the 4th plus 49x squared. Again, thinking of a method and something you might even need to do before that. So go ahead and try these 3, pause your video, and come on back when you're done. All right, how'd the factoring go? For these second 2, did you remember to factor out what they had in common first? If the answer was no, you might want to go back and check that. So the first one, though, we have 4 terms, factor by grouping. The first one can take out a b squared. We're left with 4b plus 3. Second one, we can take out negative 4. Also left with 4b plus 3. Hey, look, they both have 4b plus 3 in common. How convenient. So we can pull that out. We'll be left with a b squared minus 4. We have to check for difference of squares. The 4b plus 3 is good. B squared minus 4. Yeah, that's b plus 2, b minus 2. So we can factor that to get to our linear binomials. See those vocab words coming in? All right, how about the second one? First step, factor out what they have in common. They both have a y squared in common. So let's take that out. Now we have y cubed plus 27. Is that something cubed plus something cubed? Yes. Y cubed is y cubed. 27 is 3 cubed. So y and 3 are going to be our a and b. We just need to plug them into the equation. We have y plus 3, y squared minus 3y plus 9. Make sure that y squared is at the beginning that we had factored out earlier, and we're done. This y squared minus 3y plus 9, this part of the sum or difference of cubes, I do not think that is actually possible to factor generally. I know there's going to be a special case where it will be, but generally speaking, when you do a difference of cubes like that, you're probably done. All right, let's look at the last one. First step, factor what they have in common. They both all have x squared in common. So we can take out x squared, which leaves us with x to the 4th minus 14x squared plus 49. Then can we factor this like a quadratic? Well, we have squared to the fourth, so that's double what the first one is. So technically, yes, we can. Well, do the numbers work out? What times what is 49? That adds to give us negative 14. Well, the options for 49 are limited. It could be 1 in 49, which isn't going to be close to negative 14, or 7, or negative 7. Negative 7 is positive 49, and negative 7 plus negative 7 is negative 14. So we have x squared minus 7 and x squared minus 7, which could be x squared minus 7 and then squared on the outside of parentheses if you really want to go there. But this is fine. X squared times x squared minus 7 times x squared minus 7. 7 is not something squared, so we can leave it right like that. How'd you do on those problems? It was one of each type. It wasn't in any particular order, but that's what we're doing with factoring. So make sure you comment, put the number that's not 0 in your comment, and I'll see you in class for a few problems and some time to work.